Welcome to Maths for Matrics, South Africa's #1 destination for grade 12 mathematics. Today's lesson is on arithmetic sequences under the topic Sequences and Series, on the grade 12, CAPS, syllabus. Please be aware that this channel only focuses on pure mathematics, and not mathematical literacy. If this video helped you out, please leave a like, and subscribe so that you never miss an upload. So, let's get started. What is an arithmetic sequence? A sequence is arithmetic if the first differences between its consecutive terms are equal. So, what does that mean? Say for instance T1, T2, T3, and T4 are the terms of a sequence. This means that the sequence will be arithmetic, if, and only if, there is a number d, such that T2 minus T1 is equal to T3 minus T2, which will also be equal to T4 minus T3, together with the differences between all the terms in between, will be equal to d. The number d is called the common difference of the arithmetic sequence. The general term of an arithmetic sequence. The general term or the nth term, as it is sometimes called, is given by the formula, Tn, is equal to a, plus n minus 1 in brackets, times d. So how did this formula come about? If a, is the first term of the sequence, then the second term will be a, plus d, since d is the common difference between all the terms. And if you continue the pattern by continually adding 1, to the coefficient of d, you will realize that it is actually the same as subtracting 1 from the term number. Therefore you can generally say that the nth term, Tn, is equal to a, plus n minus 1 in brackets, times d, where a is the first term of the sequence, and d is the common difference between the terms. Now let's do some exercises. Exercise number 1. 5, 8, 11, and 14 are the first four terms of an arithmetic sequence. 1.1. Determine the nth term of the sequence. In this exercise we are given the first four terms of the sequence, and they are 5, 8, 11, and 14. In order for us to determine the nth term, we need to find a, the first term of the sequence, and d, the common difference between the terms. And if we look at the sequence, 5 is the first term. Therefore, a is equal to 5. Now let's find the common difference. The common difference is given by T2 minus T1, which in this case is 8 minus 5, and is equal to 3. So how do we know that it's correct? The differences between all the consecutive terms must be equal. 11 minus 8 is equal to 3, and 14 minus 11 is also equal to 3. Therefore our common difference d is equal to 3. The nth term of an arithmetic sequence is given by the formula, Tn, is equal to a, plus n minus 1 in brackets, times d. So let's substitute our a, and d, into the formula. Now let's get rid of the brackets. Five minus 3 is 2. Therefore the nth term Tn is equal to 3n plus 2. (1.2). What is the value of the 57th term? Now that we have the nth term, which is also referred to as the general term of the sequence, we can easily find the value of any term in the sequence. Our nth term is Tn is equal to 3n plus 2. To find the 57th term, we will simply substitute the term number into the general term.
So, T57 is equal to 3, 57 in brackets, plus 2. 3 times 57 is 171. 171 plus 2 is 173. Therefore, term number 57 is equal to 173. Exercise number 2. The sixth term of an arithmetic sequence is 58, and the 11th term is 103. 2.1. Write down the first 4 terms of the sequence. We know from the general term that the coefficient of d is equivalent to the term number minus 1. Therefore, the sixth term, T6, is equal to a plus 5d. We are told that the sixth term of the sequence is 58. So, we can go ahead and substitute the value of T6, 58, into our equation, and call it equation number 1. We are also given the value of the 11th term. So, T11 is equal to a plus 10d. Let's substitute the value of T11, 103, into the equation, and call it equation number 2. Next, we have to find the value of a and d, so that we can determine the general term of the sequence. In order for us to do that, we have to solve both equations simultaneously. But first, let's make equation 1 neater, by subtracting both sides of the equation by 5d. Now let's rewrite the new equation. From equation 1, a is equal to 58 minus 5d. We can now substitute our new equation 1 into equation 2. It looks like the brackets have no effect on our equation. So let's go ahead and look at the like terms. 10d minus 5d is equal to 5d. And 103 minus 58 is equal to 45. If we divide both sides by 5, these two 5s cancel each other. And 45 divided by 5 is equal to 9. Therefore, d is equal to 9. Now that we have our d, we can simply solve for a, by substituting it back into equation 1. A is equal to 58 minus 5 times 9. Five times 9 is 45. So, a is equal to 58 minus 45. 58 minus 45 is equal to 13. Therefore, a is equal to 13. Now that we have our a and our d, we can easily find the nth term of the sequence by substituting them into the formula of the general term. The general term is given by Tn is equal to a plus n minus 1 in brackets times d. Now, let's substitute our a and d into the formula. Let us now get rid of the brackets. (13 minus 9 is equal to 4. Therefore, our nth term, Tn, is equal to 9n plus 4. Let's find the first 4 terms of our sequence by substituting our term numbers into our general term. We already know that a is equal to the first term of the sequence. Therefore, term number 1 is equal to 13. T2 is equal to 9 times 2 plus 4. 9 times 2 is 18. And 18 plus 4 is 22. T3 is equal to 9 times 3 plus 4. 9 times 3 is 27. And 27 plus 4 is 31. And finally, T4 is equal to 9 times 4 plus 4. 9 times 4 is equal to 36. 36 plus 4 is 40. Therefore our first four terms of the sequence are 13, 22, 31, and 40. 2.2. Which term in the sequence is equal to 238? Tn is equal to 9n plus 4 is our nth term. To solve for the term number, we have to substitute Tn with the value of that term number, which in this case is 238. So 238 is equal to 9n plus 4. If we subtract 4 from both sides of the equation, we have 9n is equal to 234. Now we can divide both sides by 9. These two 9's cancel each other. 234 divided by 9 is equal to 26. Therefore, n is equal to 26. Exercise number 3. The first three terms of an arithmetic sequence are 5x minus 3, 9x minus 7, and 12x minus 9. 3.1. Find the value of x. In order for us to solve this problem, we need to remember the definition of arithmetic sequences. And it states that an arithmetic sequence is a sequence whose first difference is constant. That means that the common difference d is equal to t2 minus t1, which is also equal to t3 minus t2. t2 is equal to 9x minus 7, and t1 is equal to 5x minus 3. Therefore we have 9x minus 7 minus 5x minus 3 in brackets on the left-hand side of the equation. T3 is equal to 12x minus 9, therefore on the right-hand side, we have 12x minus 9 minus 9x minus 7 in brackets. We can now multiply the minus sign into the brackets. And now we can look at the like terms. Let's group the terms that have variables on one side and terms that don't have variables on the other by moving them over the equal sign and changing their signs. But remember, doing that don't just magically change their signs. If a term is positive, you subtract both sides of the equation by the same term, and if it is negative, you add the same term to both sides of the equation. (9x minus 5x minus 12x plus 9x is equal to x). And 7 minus 3 minus 9 plus 7 is equal to 2. Therefore, x is equal to 2. 3.2. Find the value of the 32nd term of the sequence. For us to solve this problem, we need to find a, the first term of the sequence, and d, the common difference between the terms, so that we can determine the nth term of the sequence. A is the first term of the sequence, therefore, a is equal to t1. And t1 is equal to 5x minus 3. We already know that x is 2, so we can go ahead and substitute it into the equation. 5 times 2 is 10, and 10 minus 3 is 7. Therefore, a is equal to 7. T2 is equal to 9x minus 7. We know that x is 2, so we can substitute it into the equation. 9 times 2 is 18, and 18 minus 7 is 11. The common difference d is equal to t2 minus t1. t2 is 11, and t1 is 7. 11 minus 7 is 4, therefore d is equal to 4. The general term of an arithmetic sequence is Tn is equal to a plus n minus 1 in brackets times d. Let's substitute our a and d into the formula. Now, let's get rid of the brackets. Seven minus 4 is 3. Therefore, the nth term, Tn, is equal to 4n plus 3. Let's use our nth term to find the 32nd term of the sequence. T32 is equal to 4 times 32, plus 3. 4 times 32 is equal to 128. 128 plus 3 is equal to 131. Therefore, T32 is equal to 131. We have reached the end of the lesson. Please like and subscribe if you've enjoyed this lesson, learned something new, or if you want us to continue making these awesome videos. Let us know which topic you're struggling with the most in the comment section so that we can get you sorted. Also follow us on Twitter, Facebook, LinkedIn, and Instagram so that you can stay updated with regards to all things mathematics. Thanks for watching. Goodbye.